Is this episode 30? I think this is episode 30. All right. I'm going to go for it. I might be wrong, but welcome to episode 30 of BS&BEER Canada. My name is Aaron Jones. I am a carpenter and a builder on Grand Manan Island in New Brunswick, Canada. A bit of a blower nor nut, high performance. Well, I wouldn't say guru because that's not right because we're still learning, but I enjoy a well built home. And before I introduce our very own Shaun St Amour and what he's going to talk about, I'm going to pass it below me to my friend in Saskatchewan, Justin.
Hello, everyone. Justin Ott with Element Construction. We are a custom home and renovation company focused on high performance builds, building envelope first design, and yeah, just trying to really bring high performance back to the prairies where it all kind of started. And we'll shoot it over to Connor.
Hey everybody, my name is Connor Malloy. I'm a designer, builder, and educator in Toronto. I teach full-time at George Brown College, run a buildability consultancy, and also build with my family's company. It's been great to come here and share with you all, and I'm looking forward to hearing from you, Shaun. Jeremiah, tell the folks about yourself.
I'm Jeremiah Summer, builder in Southwest Ontario. We do sort of a design build, integrated design build approach to custom building, and really like to try and continually level up our game using building science as sort of a guiding principle for a lot of the work we do. So I'll pass it back over to Aaron to introduce Shaun.
It is absolutely my pleasure to introduce the one and only Shaun St. Amour, our very own wood nut. I'm going to go with wood nut now. But Shaun has an amazing project to show us this evening, which I've had the great pleasure of visiting when it was mid construction. We'll call it mid construction or close to mid renovation, restoration. But without further ado, let's let Shaun explain this wonderful project. Uh oh. I do not know. We're
Was that Aaron with bad feet, or is that just me?
I think that was Aaron.
Okay. All right. I think he was trying to introduce me.
Nervous to
All
introduce
good.
you, Shaun. I think you should kick it off.
There we go. Well, before I get started, uh, working at Etcher Construction, just want to do a proper intro here that Etcher Construction resides on the unceded lands of the Squamish, Tsleil-Waututh, and Musqueam First Nations, and have been looking after these lands since time immemorial. And I was recently at a Indigenous workshop in construction, looking at how they're contributing to our work. And so my intro is going to change a little bit because I'm Shaun St Amour. I'm 14th generation to Canada, and I wasn't invited here, but I'm doing my best to understand how to reconcile my path and my ancestors with how we're trying to build better. And so that being said, is my passion is about resilient prefab passive houses. But before we get into the thick of things, one thing we all did very poorly to this moment in time is we didn't showcase what part of the event we're supposed to do. Because I'm going to give you a lot of BS. Hopefully, it's building science, but I get to say that we're walking a talk here at Etcher, where we're actually in a building that we've revived, and I'll explain what all that means. But in our new office, and I tell people that I actually work for a tech company that builds really cool shit, but we have beer on tap. So if you've been to Vancouver, this is 49th parallel, and the keg still has a little bit of Mother Nature's fluids in there. So cheers to everyone. Well, while either you're grabbing your beverage of choice or you're jealous that I've got one in my hand, let me throw on the slide deck, and we'll get into a particular building that I have fallen in love with. And some of you have been able to see it, and I appreciate that you came this way to check things out, and we're gonna get started here. So, welcome to Aaron said number 30. Can you believe it? Number 30 of BS&BEER Canada. And so we're going to give a bit of a tour of a building here in Vancouver. It's at 837 Beatty Street. If you've been to Vancouver, it's right across the street from BC Place. And hopefully you got your FIFA tickets and you're going to be coming out this way next year. If not, again, I'm sure we could find you some type of location for you to come visit me. You're always welcome and happy to give you a tour of this project and some of the other ones we're involved here at Etro. So you guys that have been here before, you know me, the co-host, BS&BEER Canada. I've been involved with Passive Canada, sorry, Passive Accelerator. I'm still involved with that. And now where I've been involved in getting more tours here in Vancouver with ZEBEX, which is the Zero Emission Buildings Exchange, and having some really cool tours to see other mass timber passive projects. But my main focus is the manager of Revive here at Etcher Construction, where we're focusing a specific division looking at retrofits. So at Etcher, we look at big buildings and condos. We do TIs under our dynamic ops division, and now we're also getting into industrial buildings. But very first project that Mike, the owner of Etcher, did 10 years ago. We're actually having our 10-year anniversary next month. Was actually a Revive where he, instead of demoing a house, he was able to lift it up and turn that into a duplex. And since then, being able to do a lot of really cool projects like the one I'm about to showcase you. So I hope everyone's enjoying the Blue Jays game, and I am going to keep this short so we can wrap tonight up, so we can watch Blue Jays continue on with their success. I will find a piece of paper to knock on. And so I get up in the morning to take care of this lovely family and ideally to be able to build better. And so here's the wife and kids that I'm lucky to be involved in their lives and their softball lives to keep me busy. But I'm very much driven to make them happy and myself happy. And as I just indicated, my passion is resilient prefab passive houses that I believe should be affordable. Here's some of the mentors that I've kind of used to guide me in my path in my career, and these are just four of a plethora of individuals that I've looked upon. And we always say we live amongst the shoulders of giants, and I feel like I've been able to grow and develop with their insights. And now I've been able to focus on the passive side of things and applying it to retrofits. And if you're in Vancouver, the downtown sector is only three passivist buildings. So there's a lot of work for me to do, not only in downtown Vancouver, but even Lower Mainland. So lots of opportunities. But when you look at this lovely blue rock that we live on, it's quite interesting because, some might say that we've got Elon that's going to take us to Mars, but this is something that we have to manage, we take care of. And my good friend Zach at Accelerator talks about, when we look at that blue marble, we're actually just talking about this thin blue line and how we affect it and how we're trying to save it, trying to do better within that blue line. And all of us here, I think today would agree that we're trying to supercharge our shelters. We're trying to build better and come together and ideally focusing on something called a zero carbon building. And this kind of equation here really makes it clear for me of how I can be putting my efforts in the right way. And so as we're getting to zero carbon buildings, it's not just about doing a code build and adding a whole bunch of solar panels. We really need to reduce the operational carbon. Then we look at the embodied carbon, and we can have a debate of that depending on location or province or territory, state. But those two are really the big ones. And again, we do that with models. And so we're not having to talk about opinions, it's about data. Then ideally, we're able to electrify everything and then add our renewables. And so that's how I focus on how to get to zero carbon buildings with that type of thought process. And so I'm using that same thing with our Revive program here at Etro, which is about retrofits. So we're going to take on a building and we're going to try to make it last another 100+ years. What are those core principles that we use to it? And again, that's the same thing too, is make sure the assembly is as high performing as possible, and then be able to use materials that ideally are grown from the land, be able to electrify it. And if we can find a space or grants to put solar panels on or any type of renewables, we'll do that. So this particular, and we've done a whole bunch here at, like I said earlier, at Etro, and of course the new office space that we just moved into 4 weeks ago. So it's great that I am in a more comfortable, resilient building, and I can say this now that we're getting to fall. The other building that we were in, a lot of staff had heaters under their desks, and I can say that right now we have six, and we're still a little tweaking the envelope and tweaking the mechanical systems. And I know which people are using them, and hopefully by the next month or so, we'll be able to put those in a closet somewhere. So let's talk about 837 Beatty Street. This was a building that was three floors. You're seeing the top two floors because there's another one in the lane. This building was built 1911, the boom of the kind of like the gold rush era, just before World War I. So this entire block has a very similar kind of brick style to it. And I'm actually not used to brick. I know some of you being on the East Coast have been seen and touched and been involved in a lot of brick buildings. I was definitely not accustomed to it, and this is kind of where it's at now. We've been able to add 3.5 stories of mass timber. There's actually a little bit of construction going on. Next door, there's a big giant hole that is going to be about a 32-story condo recess. So Beatty Street's a little busy right now. And how this all took shape. Actually, let me just give you a quick tour of the building. So this is the top floor. We're talking about you coming to Vancouver. Give us maybe 8 months and we'll have a rooftop cocktail, maybe before the FIFA games. But this gives you an idea of the mass timber ceiling that is on this sixth floor and this rooftop garden that's going to be installed. And so give you an idea of currently where we're at, where we're still working on roofing details and the elevator. So you can see the elevators in process and in that shape. So a few months ago, we actually installed the last panel, that first panel there right at the glulam beams. So we took a time to stop our work and celebrate the work that took to construct the building and celebrating the early carpenters and the new carpenters to create this building. We go down a floor on level 5. You can see that there's a lot of opportunity for daylight and glazing, but you can see the Western arch rib beams and columns and the NLT nail laminated timber that Kinsall, who's an installer and a manufacturer of it, that's from Vancouver Island, was able to assemble. So then we go down another floor, and this time you can actually see on level 5 here, sorry, level 4, you're seeing how the panels came together. So the NLT that got shipped to us actually had a protective coating on it. And then we added strips in between the panels. And so you kind of see that there's racing stripes. So I was telling the Kinsall group that, yeah, they did work fast. And so we need to make sure we celebrated their hard work by giving the building some racing stripes. And that allowed us to get a plane so that if any water were hit, and again, this building's in Vancouver, so I went through many atmospheric rivers and being able to funnel all the water to either to the outside or down the elevator core. This floor here, as you see, it used to be the roof, and now it's our new level 3. And you can see the rebar is getting installed, and so we're going to do a 5-inch concrete topping, and that'll be the new office space. Floor for the office space. The concrete ring beam you see around the edge used to be the old parapet wall. So there's a little bit of like that balance of showcasing history and at the same time managing the new structure. And of course, this building had to get a seismic upgrade. And so that concrete ring that goes around the building now takes the load from the upper floors and be able to bring it down to the foundation. But one thing you'll notice is just, again, real open space. One thing we realize when it comes to sprinklers, you're looking at a cove roof top, and when we get into the basement, you're going to see a coffered, because when it comes to sprinkler design, that level of detail actually matters when it comes to making sure sprinkler heads can spray water if it needs to work. Then you're seeing here is the top of that wood that's a 100-year-old ceiling that now has become the new floor, and you're seeing the rebar going in on the new space. And so this particular floor, again, not as tall as the other floors, because this was part of a warehouse, and so the general kind of store and being able to manage products didn't need as much height. But again, you're seeing how wide open the spaces are between the columns. This is the main floor where we've got bigger space. And this was used actually for driving in trucks. So being able to load a variety of material. Now, of course, that load meant that down here in the basement, you're now seeing those uh, beams a lot closer, a lot bigger. And the interesting thing is that when I first saw this project, our good friend Brian Euler corrected me that the building is not entirely mass timber, that these early floors were heavy timber. And to give you an idea, this is solid Douglas fir, 24-inch by 24-inch columns and beams, literally cut maybe 20 kilometers down. And I recently watched a Michael Green video and got re-inspired about where he was talking about 30-story buildings. And in downtown Vancouver, when we think about 30-story jungle that we're currently in, that used to be the tall Douglas fir trees. That now we're replacing the trees to condos, and the fact that we're able to recase or reestablish kind of this building and carry it on for another 100+ years is pretty exciting. That anytime that I feel like I'm not too far from the forest, I can come to this building and hug one of these beams and feel like I'm in the new forest, the new urban forest. Here's a look back at the elevator system that's going in, and you're seeing now the basement level that's getting filled out for kind of all like the typical storage that goes on with electrical rooms, mechanical rooms. Good news though is just to the left here, a speakeasy bar has taken this space, and so there's a few floors that we can explore. And at the very back is the underground to underneath Beatty Street. So this is where all the rum got smuggled in the 30s. So let's talk about kind of the building and how to manage it all. So in the basement there, this is how we had to take care of all the footings, because this 100-year-old building was pretty exciting, that it was actually designed to grow taller. It was designed to continue on. At the time in 1911, they only had funds to build the 3 stories, but they knew they were going to do more. Unfortunately, then we had World War One, then we had the Depression, and the opportunity for it to expand didn't happen for till 100 years later. So you're seeing now fresh concrete around the columns, and that's because we had to wait to make sure that all the slab working was done. But you see that different, or so the distance between the columns. If we didn't manage the foundation design properly, it would have been quite challenging to actually manage the foundation, because you can see here the original foundation didn't have enough steel. Like and our slab didn't have enough rebar, so we had to re-pour a proper foundation. But we also needed to ensure there's better shoring, and so we actually drove 40-foot piles on each of the footings to make sure that it was more secure to the ground. And then there was a lot of rot around the bases, and so you can see that real heavy steel gauge material there that was added on to make these columns more robust. And if we didn't do the micropiles at the foundation, we would have had literally no room to run any of our electrical and systems to literally go from BD Street to the lane. And so you can see the kind of work required and precision. And we're working with a really great architect at OMB, but they want millimeter precision. So all of our cut lines and pour lines needed to make sure that we had a lot of straightness in the space. We talk about what we had to do to the building. We're creating new floors, we need new elevator shaft. And so there's a whole new core that was added in. And one of the lessons learned in this sorry, just let Peter in, was the core actually ends up being not in the middle like a typical high-rise building. We put it onto the south side, and by doing that, creates a lot more open space, especially for the office, the floors that could be an office. But in that, and dealing with the tie-ins, we didn't manage or we didn't calculate the length of time it actually do a pour. And so we had posters on our wall that kind of talked about every day and what it would take to be able to do each floor and do step in. So originally we thought it would be about 17 days to do a floor, and ended up taking about 34 days. So we started construction in January 2025 with asbestos removal and removing the NLT to be able to get enough space to get to the core and be able to work our way up. One area too, when it comes to the restoration, is all the brick. Like I said earlier, I never had been involved with a brick building, and so you're seeing a kind of a 5-ply brick across. On Beatty Street had beautiful brick, and then lower grade brick throughout. When we removed the parapet, we were able to salvage brick so that when we were cleaning all the brick up, if there's any ones that didn't work out, we're able to repurpose them. And then we kept all the good ones for street level. And when we ran out higher up, we've repurposed them with ones that are the same grade. We won't be able to see that from the street. So there's gives you an idea on the second floor some of the make sure we are able to had a proper slope on all the windows and then be able to put the frames back in. So you get an idea of just kind of like the details of being able to connect the concrete. So that concrete column you see in the corner, that goes back down to the basement, connects with where there used to be a wood column, to make sure that it goes all the way up to that concrete ring beam on the third floor to help tie the building back together. And then our typical rebar, and then we even have some really thick rods that help connect back to the core and keep the slab. So the slab is actually working in as a shear load as well. There's an idea of like our mock-up window that we've had protected for many months. And so original wood frame, we upgraded the sash to double painting. And so we start to look at, okay, well, now where's the building gonna bleak? That joint there is the spot that we'll kind of look at when it comes to the air tightness details. So then, yeah, let's get into the heavy wood. Here you go. 100 years old of beautiful wood that we've tried to take care of and manage. This is level one now, where we've been able to protect the wood. But you can see here just that this was originally NLT. And so just imagine in our lane, which is just behind me here, or in the picture, that all the wood literally would have been maybe cut 10 kilometers, 5 kilometers down the road, put on rail. That log or all that wood, could have been almost like a caboose size, 8 to 10 feet in diameter, sawn up into these big beams and then brought in here, and then scaffolding put up, and then individuals just hammering away, creating all this NLT space. So you can see the connection here of the new concrete blending in with the wood, and how we connected the wood to it. There's a steel connector plate that we're able to put in. And so we actually were able to pour it in place, where we were able to cut the wood, put in the brand new steel, tie it back to the rebar, and then pour the concrete, so that we didn't have to pull the beam out and then do that concrete work. So you can see the balance of new concrete, repurposed brick with the old wood. One detail that we noticed is a lot of these columns, about 80% of them, there's a lot of rot at the bottom of the connection. So we actually had to shore up each column two at a time, cut the base off, which was about a foot, and then slide in this new steel bracket. And when I say, bracket, it's 16 inches by 16, and each one of those bolts are about an inch thick, to take that load back down. Because when you had a nail, you could literally just push a nail with your thumb a good 6 inches in. And so the structural engineer indicated that we had to reinforce all these beams that just got rotted away because of a warehouse. Trucks driving in from rain, from all the different stuff going on, rotted away those beams. But now they're good for another 100+ years. So you can see here that process of where we jacked them up, cut it off, put in the steel bracket. So now moving up, you can see the old wood touching the new wood. So that is the column on the new floor that just fits right in there. You can see the original steel. We actually added the new bolts, just 'cause a lot of those beams have a lot of checking and cracks, and so now they're kind of squished together to make sure there's no more further cracking or checking as it carries on. So in this building, again, you can see the heavy timber, the process of creating nail laminated beams. And then the client really liked NLT and wanted to make sure that that continued up for the rest of the building. So we could have switched to maybe more affordable mass timber, could have switched to DLT, dowel laminated timber. We have a manufacturer, Structure Craft, down the road in Abbotsford. We could have gone to CLT, cross laminated timber. We have Kliznikov in the Kootenays. We have Mercer lumber that used to be Structure Lam in Penticton. So, and we've got other mass timber companies in the US. But great that the client had a vision of continuing that view and working with OMB and Intuitive, who is the envelope consultant, was able to balance a pretty beautiful design. So really taking care of the form while ensuring that the function was great. And so you can see now that transition from that darker floor to lighter floor. As we were building up, we preloaded our floors with the plywood, the rebar, and even the windows. And so all the glazing was already pre-done as the mass timber arrived and got installed. So if you take a step back here, before the mass timber got installed, you have that concrete core coming all the way up. So you think of the phase, we had asbestos and demo removal. Then we had to remove the NLT to create the space for the concrete. We did all the concrete, new columns around the perimeter. Then we did the core. Then we did the ring beam around. And now the fun part, which I think was the fun part, was the mass timber coming together. So you can see the columns and beams come together. And now let's talk about some of the high performances, because we're kind of halfway through. So now we switch to high performance. And so how do we make this box airtight? How do we ensure a really excellent sweater and high performance? And so I appreciate it. So I had coffee with OMB, the architecture company, and was kind of looking at their principles and what they're trying to do. And I had already gone down. Oh shoot. I went to the basement and we were doing our foundation work. They were like using a green poly on the floor. And I was like, wait a second, this is not the right spec. This is more sophisticated. And they added 4 inches of insulation in that basement slab. And then I realized, okay, these guys are doing something sneaky, and they believe in passive house. They wanted to do the right kind of details. And so in the retrofit space, this is not an EnerFit project. They wanted to go down that route. The client didn't want to spend the time modeling it. So they did as best they could to ensure that with current modeling for the City of Vancouver's energy requirements, that they did as much sophistication as possible. So when I was able to talk to them about how to manage it, they really appreciated me and our air boss that were on this job. And so the air boss came from our first passive house multifamily project. And so him and I have been able to collaborate for a few years now. And so now we're trying to make sure that this building will be as airtight as it can, knowing that you've got some older elements to deal with, and potential new penetrations, and so trying to figure out those details. So one thing before we get into like the passive principles is just more of the seismic upgrades and how we're managing it. So originally those wood columns, the wood beams, were sitting in beam pockets in the brick. And so we were able to remove those and put in those metal connectors and then pour a new concrete column to help replace that connection. So the building would be properly seismically upgraded to a new structural loads. Gives you an idea of like heavy metal, the rebar work required to do our concrete core, with the concrete core being where it was located, took a lot of effort, but you can just get an idea of the heavy metal involved in there. Talk about fire safety. So all of the connections, so these ones, so the top white one, is 100 years old. The bottom one was redone, and then we've added those bolts through it. So you got a combination of some new and old connections, but from a fire safety standpoint, we've sprayed this with a fire safety paint, and then again, it'll be painted black. But again, just making sure that not only was the building brought up for the seismic, making sure that if there was a fire, that the timber would be fine, because we all know when we've had a campfire, that these big logs char. But we need to make sure that the metal is managed as well. So we get into our kind of classic Pascal's principles, looking at high performance windows, the sweater, the continuous fresh air machine, the air tightness details, and the thermal bridges. Let's go look at kind of the red line tests of how to manage this. So for the most part, it's a box. It's pretty good. The upper patio up top gets a little bit interesting, but again, that challenge of now relying on the existing brick as an air barrier before we get into the newer upper floors. So as I said earlier, it was great to see a vapor barrier that was more resistant to kind of the pulls and tugs of a typical rugged construction site. So I realized that the team that was involved here was trying to do something better than normal. So I've got our 18 mil poly, and then all those penetrations you saw earlier were definitely detailed, and then that continuation across the floor. So you literally have the vapor barrier going across, ties into the concrete. Concrete then becomes the air barrier up to the brick. Here's that picture of the connection between Beatty Street and the building. And so the property line is that inside cove. And originally there was that cove actually continues underneath Beatty that we had to give back to the city. But this was the pathway for smuggling booze in the 30s. So then you get up to window detailing. And so all of the original window frames were pulled out, but put back in. The sashes were put brand new, but we did work through all the details around the window to ensure that one, water wasn't going to find a way in. So you can see we poured some new window sills, but when we put the window in, made sure that again, it was air sealed to the brick as possible. And now the question will be is, how porous is the brick, and being 5 layers and being repointed, how well it will perform. We're going to wait and see. So you can see here, yeah, this is the new sill that was added on to ensure that it has a back dam and a sill to ensure that water can go down and out. And every time I get on this floor right now, we've now upgraded it. So the metal hardware will be black, the window frames are black, and this is some of our leftover brick that we're repurposing on this floor. But the connection of old and new, I just kind of fall in love with this building every time I get to go see it. So we get up to the newer floors. Again, you've got this amazing heavy mass timber that's working for the structure, but now how do we surround it in an envelope? And the client really wanted to ensure that it was high performing as possible, but also a lot of daylight and connection to the other space because as you saw earlier, BC Place is right across the street. And so there's needs to be something to be robust. And so the balance between the heritage design and the new kind of modern look, I'll get into a little bit later, but one of the details was to put in this precast stone that runs horizontal between the floors. And so there's a metal bracket that needs to hold that. But can't just have metal on metal. We all know what thermal bridging does. And so that green product is actually again a insulating plate to ensure that it breaks up that piece. So Armatherm is this particular. I know we've seen different colors. I don't quite know what spec it was to get the green, but this is a detail where the metal plate is connected to the end of the CLT slab. You now have this thermal break between another metal connector that's going to hold this stone precast stone piece. So if you're kind of looking down at, hopefully you're not getting sick looking over the edge of the scaffolding down, but you can see now we've added an exterior, sorry, the vapor control layer that's vapor closed on the outside, because that actually now is going to be the kind of the warm side of the wall. And you're seeing their window details. And that window frame is from Blackcomb Facade. So we've got one of the best window on the market. So this is Ryco system. It's similar to the Schuko. You could debate of which German 100 years ago copied one from the other. But anyhow, it's high performing window. And you can see that even the insulating plate has now been water sealed. So we actually did a liquid applied membrane on that because again, like dealing with air tightness and with water in those bolts. So that now is waterproofed, and everyone was happy with the different layers to ensure the water could go down and out. And you can see just again like that now connection of managing the the kind of encapsulation of the board and being able to tie it into the windowsill. The picture here on the right is that stone that comes down. So now you can see that it's bolted on. You might be able to see just between right at the window, there's a difference. So in front of the window, the precast was actually made with a slope. And then in between that slope is where there's going to be a brick. So there's a lighter gray brick that will return back to the window, be full of insulation with rock wool, and will continue on. And so you're going to have window, brick, window, and about 50% of the new floors will have a daily option. The picture on the left now is below the stone and how we've now trying to make that connection to the original brick. And so that ring beam is behind that rock wool insulation, and now all the brick you see there will get reinstalled to fill the gap between the stone um, ledger that's going all the way across and fill in that gap. So they're in the process of, and but now you can see, sorry, the white membrane where again we ran our pin and stick down to the top of the brick again on an angle. So if any water got in behind it, it will always find its way to go down and out. But originally it was just all flat. You know, like 100 years ago, they didn't think about how to build in a rainforest. Well, now that we've learned from our leaky condo era and we're trying to do some better practices with multiple layers of protection for this building. Coming back to that brick, you can see in behind that stone was this particular metal bracket that got added on, and those precast stone pieces are about 8 feet to go between two windows. That how we actually installed the scaffolding about 18 inches off the new wall, so we were able to slide the precast down with our crane to be able to land it on these pieces. And now you're seeing, the top of the windows that we've added a flashing in there to ensure that once the stone gets on, that there's no way for water to get in behind that window. On the interior side, these high-performing windows got clips. We're seeing that a lot now on high-performing window. It's a pretty standard thing now of just making sure that we've got that clip connection, and so kind of reducing that thermal bridge detail on the inside. These windows, to give you an idea, are like 3 foot by 3 foot, and that gap is 10 feet tall. Those upper portions. So just transitioning now from the high performance details to some of the things we're doing with innovation here at Etro. The number one is that we're trying out prefab. The first method of prefab we're doing on some of our multifamily projects is where we're bringing all the door hardware and bathroom hardware to our warehouse where we're picking it and make sure that when we bring the door hardware to the suites, it's only for what we need. I'm sure you guys will find too is, the amount of cardboard that ends up on a job site after the finishing stage. Just imagine on a high-rise building that you end up having all of your laborers just moving garbage and recycling. So the fact that we have a warehouse that actually is where we store all of our equipment, and so we kind of have our own tool rental company at Etro. It's one of the different businesses that we have, and so at that warehouse we have space, and so all of our materials arrive there. The warehouse crew can actually be a logistics portion of the company and be able to ensure we've got everything, get rid of all the recycling materials, put it into a tote, and ship it to site. The second one is what you're seeing here is a prefabricated bathroom wall. So earlier on, I was saying that when we were loading up our floors, we had our windows being stored in those washroom areas to ensure that we had safety. And by doing that, we weren't able to construct the bathrooms. So it gave us an opportunity to do some R&D. And at our warehouse, we actually built all of these bathroom walls. They're not pods, they're walls. And that is going to be the one side of the washroom that's required. So it already had its wall-mounted toilet and sink. And so you can see, so this is our mock-up. We took off the finishing details. And now this particular size will be able to fit in every single floor. The first floor that's really tall, we're going to add in, 4 feet of material on site, but that's going to be shorter runs, and yet all the major components are already installed on the for our bathroom walls. The next one is using our VDC. So in Etro, we have a team of 5 that's doing our virtual design and coordination. And it's really exciting where in a complex building, especially like this, where the architect wants precision details for where sprinklers need to be, where lights need to be. And so being able to have this tool to show the site supers, the specialists, where things need to go. Because again, 2D drawings, they work, but be able to hold up an iPad and say, hey, like this is exactly where it needs to go is critical, especially in some complex areas where our mechanical ducting is just, it's so tight. And we had to sequence of being, we need to do this one here first before we do the next one and be able to review that with our specialists and have discussions of which one do you want to prefer? Well, we think this, and be able to work together to ensure that every trade really knew when they needed to attack a certain zone to ensure that they could be able to do the work they needed and get out in a timely fashion. So one thing that we did was celebrate, and I don't think sometimes we celebrate enough of our projects. And when I was working with my dad, we would stop, and he really embraced the opportunity to just ensure that we celebrated the small wins. So when you think about this particular building, from what it was and to where it's going, one way that the architect celebrated the design was you can see on the left of what the building looked like with the parapet walls. They took that off, and then they're like, well, do we just celebrate the building by continuing that look and that facade? Well, they realized that in the design, um, originally in the pre-planning, working with the structural engineer and the designs, that the building was ready to be adding more floors. And so they decided to kind of celebrate the wood, and then be able to give the individuals that are using the space a really nice look. So you can see the old material that we're bringing back. So that white building you saw earlier on, now it's been sandblasted with these glass beads to take off anywhere from 7 to 12 layers of paint to get it back to the brick. So now it'll be repurposed on the lower half, and then the upper half, you're seeing high performance glazing, thin lines, so that the occupants can really enjoy um, really being involved in the space with a holistical approach with, seeing all that mass timber and all that wood, and then being connected to the neighborhood. Because again, with BC Place across the street and some other beautiful buildings, it's nice to have that view. So that's where we're heading. The next 3 months, the scaffolding will come down, and I'll be able to show you what this really looks like. Again, earlier on, I talked about how we did the celebration last panel. That's what that last panel looked like. So that's a 4 foot by 10 foot billet that they would make, and Kinsall brought it all over, and quite quickly we were able to erect all the columns and beams and these NLT pieces. So there's that main floor picture I've shown a few times, and ideally, the power rendering. That's what that bar is going to look like in about maybe 6 to 8 months. So I invite you over at any time if you're ever in Vancouver. Happy to show you where we're at, and hopefully further on you'll be able to enjoy a point. So the client wanted to create more office space, and really wanted to rely on offsite construction to help speed up the project, and really wanted to celebrate NLT and be able to continue up into the new space. And of course, can't do it without collaborating with a great team. So between the owner, ourselves, the architect, and all the different consultants and engineers, we're lucky to work with a great team. And it's been fun talking to our heritage consultant just about the neighborhood and what it was, and they're quite happy that this building's going to continue on for another 100 plus years, maybe 200 plus years. So if you want to scan that with your phones, the QR code on I guess on your left, we actually created our own website for this particular project. So you can learn more about the foundation work, the mass timber stuff that we did, the VDC, and also the prefab. So It's been a fun showcase to tell the project to you guys, and with other kind of like the other people. We had a Woodrise conference 2 weeks ago, and we had 21 delegates from Japan that were pretty fascinated with the project, and we're trying to show as many of our building community this project. So I really appreciate the opportunity to share where we're at currently and kind of where we're headed. And if you're not connected with me, scan the other QR code and we can get connected. But yeah, we're here at Etcher. We're builders, and we're quite happy trying to push boundaries and push things to the next level. And um, I'm going to stop and have a sip of my beer because I've spoken for a little while. But I'm happy to take on any questions, any comments you had about this very unique building that is been able to look at heritage, continuation of our wood industry, and then also applying high performance techniques to this remarkable building. So, cheers to you guys. Thanks for letting me speak.
Maybe we can jump in. Dude, that's a wicked project. It it's got all parts of it make me excited and stressed also seeing those details and penetrations coming through all those conduits and rough-ins through the slab in the basement. We have certain trades stress out when we want like 5 conduits brought through the slab in the right spot. So that one kind of gets me excited. But I'm curious, so many of us here come from the single family building or maybe even
Yeah,
multi-family, and that's also your background. Maybe you can
yeah.
tell us like what for you has been, I guess, the most similar in terms of what you're managing or being challenged by, and what's sort of like a brand new to kind of take the building science piece to something that's a building of this scale.
Yeah, great question because Um, what's great is building science doesn't change on the building. It doesn't change in the climate. You just have to understand where control layers need to be and be able to expand it. This is a beautiful box. So I would say somewhat easier to kind of manage because a lot of our single family homes have a lot of more corners than there should be. And so working on not only this project, but even other projects. So I've kind of become like the master air boss for the entire company. And we have um, five, I'd say, big projects that are anywhere between 20 and $80 million. And then we have about another 20 to 30 smaller projects that range from $100,000 to 5 million. Um, so what's great is every building needs to be wrapped, everything needs to be gift wrapped, everything needs a sweater, and ideally high performance windows. And um, from being able to be a builder with that experience has allowed us to, it's funny, we don't talk about value engineering, we talk about optioneering. And so being able to look at saying, hey, we want to do better layers, levels of air tightness. And by doing that, there's a return on our mechanical systems. And so that language doesn't change from single family homes to these buildings. The difference is the budget. Um, when I want to save like $2 or $5 million in mechanical system, it makes sense because it's like an $80 million, project. So there's more zeros between the single family and the bigger buildings, but the science doesn't change. And where what kind of drove me to the retrofits was just I want to be challenged. And I love that in Vancouver, the the BC Energy Step Code and where we're heading by 2032, we're going to be mandated to build passive house levels. And this opportunity came where, like I said earlier, there's like 3 buildings in downtown Vancouver that I don't get to touch because they're already passive house. But every other building needs to be fixed to some level. It's unfortunate that Vancouver has gone through a leaky condo era, and we tried to fix the building so water wouldn't come in. It would have been great at the time if someone knew that passive house principles were coming in, and we should have added better air tightness and better levels of sweaters to that time because those ones will probably need to get fixed in 20 years, and it's a shame that that's going to happen. So a long answer for you, Connor, but I would just say again is the science doesn't change for sizes, but the retrofit market, it's more research, more investigating, more puzzles that kind of makes me work on my craft as a builder and try to be able to work with and collaborate with more individuals and to be able to kind of teach another part of our industry that is not quite there yet. Single family home builders, I think, have had a bigger uptake on it because they're doing everything where I'm now working with specialists, like really working with the window installers and envelope companies and insulators that haven't had to worry about managing air tightness because it's a big building, and now we're pushing them to new levels.
Cool. Thanks, Shaun.
Yeah.
I got a couple questions for you. I'm
Go
really
ahead, bud.
curious about the nail laminated uh, system, and I'm curious. I want to know how big are those joists? That looks like those are like 2 or 3 inches thick, at least on the old part. I don't know what that is on the new floor system, but what is that made of?
Yeah, sorry, I said kind of like the size of the billet, not the size. So it's all 2x8s, um, and and so yeah, you're right. The original would have been a solid 2x8, where the new ones is just nominal size, and um, and interesting too. So the process that Kinsel had was just imagine literally a tent by on Vancouver Island by the water where three guys, carpenters, got nail guns and they're just plowing out 4x10 slabs and a forklift operator bringing in lumber, picking up the slab and then stacking it up. And 3 months later, the order got filled and it came over, and then they installed it. Oh, I mean, again, in the process too, they made the slab, put on plywood, did that um, water repellent product, and then on site we then put in the splines, the plywood splines, and then taped it over to give it the racing stripes. So
Yeah.
that's what the mass timber comprised of, and again, the client wanted the same look. They could have chosen DLT,
Mhm.
CLT. And I would say in the last year, we're probably going to be seeing less NLT and more DLT and CLT just because of economies of scale with what local manufacturers are doing.
Yeah. And the on the masonry part on the lower area, is that brick being left exposed on the inside, or does that
Yeah,
get like some kind of a coating on it to protect it, or it's going to be part of the aesthetic?
yeah. So the exterior will get a wash more for just like some water management. But knowing what our friend Adam White has with Intelligent Membranes, I would love to bring some of his products over to add that to the exterior because technically, like, there's no air barrier, right? Like
Right.
the brick and the mortar is it, but we all know porous and pinholes and all that stuff. And other retrofits that we've seen, they've applied, Viscon or a liquid applied product to the interior side, and so that beautiful red disappears and becomes white. But I'm happy because there's a proper air barrier there,
Yeah.
and we've seen some cool projects on the East Coast that have done that. So and when I got involved, I was asking about it. We've got another revived project in Vancouver Island that it's going to turn into a Hyatt hotel, and in their restoration, they are putting a liquid applied to the inside of the brick. So I was happy that that particular project understands a bit more on air tightness than this particular effort. But again, we every project has its pro and cons, and now more of us are involved in asking questions about, hey, like, there's no air barrier there, or hey, we can make a better air barrier. What other solutions do we have?
But I guess in a case like that too, like on that particular level, the air moving through, like there really aren't materials within that wall that are at high risk in a lot of ways. Like that wall's not, there's not wood integrated in at least that part of the assembly. So it's kind of a something benign material that is allowing some air and moisture to pass through and dry kind of like wherever it needs to go versus, modern buildings where you may have some combination of materials mixed in there that could be a little bit, you know, less durable.
Yeah, so we removed, in a sense, all those beam pockets. And I mean, the beam pockets are fascinating because, like, when I first saw it, I was like, "Oh, this must be like an old chimney or something." And then you hear the story of like a beam pocket, and then you see some of the projects like that Michael Ingui does in Brooklyn, and where they've got all these joist pockets and stuff. It's pretty cool to kind of like see that like that structure, how it's like, oh well, brick's gonna hold enough, it's good. And
Yeah.
now in our seismic zones, like, okay, no, we can't do that. But you're right though, like to have the wood sit in like an elegant structural engineering bracket that's hidden, and you've got like six little pins that now connected to the steel plate that's connected to the concrete that's sitting in front of the brick, and you're like, yeah, like from a water management flow and in vapor flow, it's great that the wood is way more protected than it was. But then, and additionally, like the layers we did were now that brick ledger, we poured proper slope. It actually like a 5% slope to make sure like really we're keeping water away. And there's not enough time, but a couple other pictures I could have shown you is where the 100-year-old metal header above the openings got rusted completely away. And we're now, redoing that one. But again, like the testing we had to do to just sneak in there and be like, how good is that steel? And is it going to be okay? Or how do we reinforce it? Do we leave it and put a new plate in, which we did on the first floor, but second floor we had to remove the brick and remove those header to replace it. So, it's great working with the craft, like our masons that like there's one guy that literally pulled every brick off, fixed it, put it back in the pile, and he's been doing it for 6 months, and he's like our brick whisperer. Like you don't bug him because he's brilliant in those efforts.
Super impressive. That's really cool.
Yeah, thanks. Well, I know we're getting close to the hour, but I'm happy to sit here for a bit and keep drinking my beer and sharing stories with you. So if you do need to leave, I get it. But if you got other questions, I'm happy, or comments, I'm happy to carry on the conversation.
I'll just sneak on while everyone else is being quiet. Yeah, we had an opportunity to tour that site, and just honestly, at the stage it was at, walking through, trying to imagine building that building in the early 1900s, dragging those timbers in there, and just the tribute that you guys have done to that original construction, moving forward with all that timber is just absolutely amazing. I was teasing you in a text. I was bugging the wife if I could come work with Shaun for a bit on this project because it's just absolutely amazing. And unfortunately, she's saying no. But yeah, it's just very cool, Shaun. Yeah, I'd love to come back, and see it again, and see some of the other projects you've been working on. It's really cool that you were able to get on with a company that specializes in really reviving those old buildings. It's very cool.
Yeah, part of our revised story is, we're restoring, we're rehabilitating, we're reinventing new spaces, and it's great what having a vision of again being an early adopter. Like not too many people are doing retrofits. I would say in the last 6 months, it's been interesting with it's interesting in the retrofit market because our good friend Adam James, who with Ryder Architecture, um, his company in the UK actually kind of gave me a bit of a model of like how retrofits occur. Mostly they either happen for like right now electrification. Then you're like, oh, we're going to electrify the building. We need to look at reducing the energy load. So we need to upgrade the windows. And if we're doing the windows, well, we might as well upgrade the mechanical system. And then we should put in a continuous fresh air machine. And so all of a sudden, like the high performance stuff kind of comes out of another story, or it's supposed to be a TI. And while they're doing the TI in, that's more of like an adaptive reuse, we're going to change the space. Well, we're going to having to upgrade the boiler. Well, if we're going to upgrade the boiler, we should do electrification. And then you're all of a sudden you're doing some high performance stuff. So it's really cool to see how a building will continue and then it takes into a whole new level. So it's great that these stories and how they come about and what clients are trying to do and then seeing a return on investments. Um,
Right.
like I haven't had a chance. I've talked to the owner a few times, and we carry on about how beautiful the project is, and I kind of keep forgetting, like why are you doing this? I mean, this is not their first project. If you've ever been in Vancouver, on the other side of Beatty Street, there's another bar called Chambar, and it's a great Belgian beer location, and they added more of a glass box on top of their building in their office space. And they did do some, upgrades, not to level like this. So seeing, a client understand the privilege of buying a building and being able to restore it and not demo it and then turn it into an elegant place and having a vision being like, I want the bar on the main floor to be the best bar in Vancouver. And we'll find the client, we'll find the person, but I want to make sure that we give them the space to have an opportunity. And that vision is just it's pretty cool.
Yeah. No, it's absolutely amazing. And I think about, kind of like all that capital investment, I guess, if you will, that they're putting into that. And I try to understand the different markets. And, we have some pretty old buildings here in Saskatchewan, and it's just like, could some of that same stuff that you guys are looking at out there, could it work here in some of our downtown buildings and really try to get my wheels spinning? So yeah, it's very cool.
Yeah, I would say the thing that's great about it is, if the client had to just fix their original, 3-story, 100-year-old, that would be great. But being able to double the size, and just, tell more of a story, like it's not a retrofit, it's density, and like you couldn't have done this building maybe 20 years ago, right? Because we didn't have the mass timber the way that we have now, and so all of a sudden the right timing of them acquiring this building and having the right engineers and the right team that were skilled enough to put all the right pieces in place. It's pretty fortunate to again to be involved, but also be involved with a great team, not just the consultants, but also then the skilled trades that are out there working. I like honestly, we Kinsel and Seagate are like pretty much North America's two best mass timber installers. Seagate literally was just down installing like the Cleveland, or sorry, Cleveland's mass timber, but now the tallest one in Milwaukee. Kinsel travels all the way around, and to be able to work with them, and then the individuals that are installing the sorry the precast um, kind of horizontal material, to be able to literally, in the crane, drop it down this little thing without cracking it on any pieces, and then landing it, and then getting it to be millimeter precision on those brackets with hinges. Like they do some of the most amazing prefab stuff ever, and those two crews out of some of the, and then we have Blackcomb Facade doing our window install, and they're one of the best passive house glazing companies in BC. So, again, like you can tell, like it comes at a price, but when you have the right people doing the right work, your quality control and quality assurance is pretty easy because you're just like, oh yeah, that's done well, and you move on. You don't have to be like, oh, we need to fix this and manage, how it affects the schedule and the budget on these big buildings.
Yeah.
It's
Awesome. Well,
interesting.
thanks again for sharing, Shaun.
Yeah.
It's interesting that you mentioned maybe 20 years ago it wouldn't have been possible, but yet 100 years ago there were plans to go higher with what they had. Like it's like the heavy timber industry fizzled out when steel and concrete became more common, and then you skip almost 100 years, and now we're back to being able to do it again, which is pretty interesting.
So down the road, I mean, if anyone's been to Vancouver and you've been to Steamworks, that used to be the Hudson's Bay's first warehouse. It was 9 stories, and that was literally the tallest mass timber building in the British Empire for literally until um, the Brock Commons was built at 18 stories at UBC. So,
Yeah.
we were building these heavy timber buildings up to 9 stories, a couple of fires. We think that we can't build with wood anymore. We build platform frame construction, bloom framing for, 80, 90 years. And then we, figure, okay, well, we don't have heavy timber anymore, but if we glue wood together, we can build these different components. And all of a sudden, enough engineers focusing in the wood products industry. And this was so great about the Woodrise conference. I was here three weeks ago. 20 of honestly our industry's greatest minds, architects, engineers, creating this wood industry and some of these early projects. Like you think of the Richmond Oval that was for the Olympics. That created structure craft. That was that second project of theirs, now is creating a prefab mass timber company that is doing some of the most remarkable mass timber in the world. Like the stuff that they're doing in China, mind-boggling. Like it is, and you think of the World Expo in Osaka that just wrapped up last week. most of those buildings for the various countries that were there built out of mass timber. And like I just was drooling every Monday. I'd get a post from something there, and it was incredible that we're pretty smart people and we're pretty creative, and being able to use this natural product that is just storing all of our carbon that we're creating in our environment to just store it for 200 plus years and then be creative and manage function and form. It's exciting times for all of us. I mean, even I got another project that I'm brewing for next year, but I'll give you a quick tidbit for the millions and millions that are fans that are still out there right now. The We're doing a side project of mine where we're building a brand new house, and 40% of the wall panel is made out of reclaimed lumber from since the urban forest, and be able
Wow.
to do it with prefab. Is going to be another cool project I'll show you guys in the spring next year. But the creativity of doing things, and we're also deconstructing a big warehouse and hopefully creating a mass timber building. And so to say that I've gone to the urban forest of Burnaby to create a mass timber building in Burnaby, 20 kilometers down the road. I mean, I would have never thought that I'd be involved in a project like that and try to put
Yeah,
pieces together. So
that's cool.
it's pretty cool to see what all of us are up to in our own individuals. And I mean, this is why platforms like this are just so great for my soul, and to be able to share and learn from everybody. I mean, it's a great group that show up every third Thursday to the BS&BEER Canada group, and the other ones that we intermingle with. I mean, a lot of our friends that are hanging out in Dallas right now, and I mean, it's pretty cool to just be able to vicariously live through us. And we've got some friends that are right now in Sweden on a prefab tour with the Canadian Wood Council. So, it's exciting that we may not have the time to do it, but when we stop for an hour and just catch up and share, what we're up to, it's exciting. So I appreciate everyone that's shared before me and that will continue to collaborate with us and keep passing on our wins and our losses.
Very cool.
Well, if there's no more questions and comments, I mean, I'm happy to hang out, but if everyone else wants to go watch the Toronto Blue Jays have a great game, we probably should start thinking about Blue Jay ball.
Probably a good idea.
All right, you guys. Well, thanks again for letting me speak and share, and always great to see you guys. And we'll see you next month, if
Great.
not sooner.